This is a plastic model of a dividing head, and its job is to divide a circle up into even parts. It can be used several different ways. If I turn the crank on the back here, is called simple or plain indexing. If I rotate the spindle, it can do what's called direct indexing. I can also use the crank handle to do angular indexing, or I could do differential indexing. If I turn the crank handle here, what it does is it turns a bevel gear on the bottom of this crank handle, which turns the shaft on the bottom, rotating the worm. I'll reposition the camera in a minute to see that, which turns the worm gear. Now each revolution of this crank handle will move the shaft on the bottom one revolution, which causes the gear that it's mated with to move one of the number of teeth. This particular gear has 40 teeth on it, so what we have is a 40-to-1 gear reduction for simple or plain indexing. Here's another angle of the worm and the worm gear in mesh. Again, if I turn the crank, you can see the worm starts to spin, which drives the worm gear on top. And this is causing that reduction. This will cause the chuck to turn, which is on that shaft on the top, which is the spindle. If we want to cut 7 equally spaced flats around a diameter, we can divide the 24 direct indexing plate by 7, and you'll get a mixed fraction. We can divide the 30 direct indexing plate by 7, and again we get a mixed fraction. Let's try the last one, the 36 direct indexing plate on the back divided by 7, and again we get a mixed fraction. So we can no longer use the direct indexing method. So what we have to use is what is called simple or plain indexing. And basically what that means is we have to engage the worm with the spindle again, and on the end of the spindle is that worm gear. So the worm has to be engaged with the worm gear, if you remember back to that plastic model I showed you. So what we'll do is we'll try and get that engaged. So we'll loosen this bolt and see if we can get it to drop in, and I may have to actually wiggle the crank pin on the front in order to do that. And I believe it is in, so we'll lock it in place. We also, too, want to make sure that we have disengaged the spindle on the other side. Well, looking at the front of the dividing head, you will see the hole plate. This one is used when we are working with a 40-to-1 gear reduction, or we are doing simple, plain indexing, same thing. You will notice we have a hole plate in here, and it has several different diameters of holes, starting at 15 and this one ending up at 49. Depending on the manufacturer of the hole plate, we will have several different ranges of hole circles. In other words, there will be a few different plates for the dividing head. Now, if we take the 7 divisions we require and we use simple indexing, the formula is 40, because there's 40 teeth on the worm gear, divided by the number of divisions required. So in this case, because we want to make 7 flats, it would be 40 divided by 7. That works out to a fraction of 5 5/7 of a turn. Now, again, because we have that mixed fraction, we can't use direct indexing, so we have to use simple, or what is known as plain indexing, with the worm engaged, in this case making a 40-to-1 gear reduction. Now if I take that denominator of 5 5/7 and I multiply the denominator, the 7 part, by 7, it should give me 49. You will notice we have a 49 hole circle on this hole plate. So I need to make that 5/7 fraction, same fraction, only larger. So what I'll do is multiply both the numerator and the denominator by 7. So 5 times 7 should be 35. 7 times 7 should be 49. So it should be 35 over 49. So in other words, that 5 5/7 fraction now becomes 5 complete rotations of this crank pin, and then 5/7 of a turn on this hole plate. 5 times 5 is 35, so I want to be 35 holes on the 49 hole plate division. So what we'll do is I will set the crank pin at the top, and I'm just going to take the sector arm and push it up against it. Now, there actually is a screw just in behind here on the sector arm, so if I loosen that, what I can do now is I can manipulate this other sector arm. And I've already gone through and made a mark where I need to be. So what I would do is start counting the holes on the outer diameter of this. Never ever count the hole that the pin's in, so I'd start counting from the next hole all the way down. And 35 holes on a 49 hole plate will put the second sector arm here. So I'm just going to tighten that screw so that sector arm doesn't move. And what we want to do is when we end up indexing, we want to, so we'll cut the first flat and then we'll pull this out and we will go clockwise 5 complete revolutions back to where we were. 1, 2, 3, 4, 5, and then we're going to go that 5/7 of a turn, or 35 spaces on a 49 hole plate. So I'm going to come around close to this other sector arm and I'm just going to let the pin drop, and then what I'll do is tap it till it drops into the hole. Now we're ready to cut that next flat. But we want to reset these sector arms, and I'm going to take the sector arm that will sit up against this crank pin and I'll push it around. So the next time round it'll be 5 complete turns and around to here, and we'll keep doing that until we go 7 times. I'm going to start at the top though, or the 49, just to get us going. Again, I always want to push the sector arm that's going to sit up against the pin. Alrighty. So I'm going to bring you around here, and hopefully you can get a pretty good idea of the whole thing here. Okay, and we'll turn the milling machine on, and we're ready to cut that first flat. I don't need to turn the milling machine off because my hands are nowhere near the spindle. I'm going to be out here on the hole plate. So again, I want to pull that pin out, 5 complete revolutions. 1, 2, 3, 4, 5, and 5/7 of a turn, or 35 spaces on a 49 hole plate. Drop the crank pin on the plate and just tap it till it pops into the hole, going clockwise. Take the sector arm that the pin was on and push it around until it is on the pin again. We're ready to cut that second flat. Make sure the cutter is clear of the work. Again, this time I'll bring you around so you can see what's happening with this hole plate again. So I'm ready to cut the third flat. Pull the crank pin, go clockwise. 1, 2, 3, 4, 5 complete revolutions, and then 5/7 of a turn. And again, I want to set that sector arm. Always use the one that's going to sit up against the pin. We'll come back around and have a look at how the part is looking. And this time I think what I'll do is just leave the camera right there, because I think you got an idea what's happening with the indexing. Third flat. Ready to index the dividing head. 1, 2, 3, 4, 5 turns, and then 5/7 of a turn. Set the sector arm. Cut the fourth flat. And it's starting to take shape. Again, index. 1, 2, 3, 4, 5, and 5/7 of a turn. Set the sector arm. Once again, index. 1, 2, 3, 4, 5, and 5/7 of a turn. Set the sector arm. And I believe we have one more left. 1, 2, 3, 4, 5, and 5/7 of a turn, and this should be the last one. What I'll do is I'll run the cutter back through just so the table is closer to us and we can see what's happening. Turn the spindle off, and let's have a quick look at this. So if we go clockwise around, we have 1, 2, 3, 4, 5, 6, 7 equally spaced flats. The size of them will be determined on how far you bring the cutter down into the part or bring the table up into the cutter. Your choice. If you take that 5 5/7 and multiply it by 7, it should equal 40. In other words, it's the 40 revolutions of the crank pin in order to give the spindle one complete revolution. That is simple or plain indexing.